Thanks for all the students. Uh, and I hope I didn't color my hair, so you can see that I'm reasonably young. I did my ECE degree from Andhra University. I think it's the Luxury Store. Yeah. Oh, sorry. Please go ahead. Please, sorry.
Good evening, everyone. Welcome you all to this expert talk session, which is being conducted in association with Alumni Association, Andhra University Alumni Association, and being sponsored by ISEA project. So, to begin with, let me call upon Shashi Madam Garu, Principal of the college, onto the dais. I request Rao sir to please come onto the dais. I request our Dean Alumni Affairs to please come onto the dais. And anyway, we have with us here our speaker for today, Shri Ramesh Karigaru, who is a professor of electrical and computer engineering at New York University, who is also an alumnus of this campus. He was an 81, 85 BTech in ECE batch. So may I request all the dignitaries to please be seated. So let me quickly introduce Professor Ramesh Karigaru. When the laptop gets connected, so they've just gone for the adapter. So Ramesh Kari is a professor of electrical and computer engineering at New York University. He co-directs the NYU Center for Cybersecurity. He also leads the Cybersecurity Trust of the New York State Center for Advanced Telecommunications Technologies at NYU. He co-founded the Trust Hub and organizes the Embedded System Challenge, the annual Red Team, Blue Team events. Professor Ramesh Kari has a PhD in Computer Science and Engineering from the University of California at San Diego and a BE in ECE from Andhra University. His research and education activities in hardware cybersecurity include trustworthy ICs, processors, and cyber physical systems, security aware computer aided design, test, verification, validation, and reliability, nanometer security, hardware security computations, benchmarks and metrics, biochip security, additive manufacturing security, lots of them. He has published over 200 articles in leading journals and conference proceedings, and he works on hardware cyber. His works on hardware cybersecurity received Best Paper Award nominations in several reputed international conferences and several ACM student research competitions and ACM grand finales, Kaspersky Challenge, and Embedded Security Challenge. He also received the Humboldt Fellowship and the National Science Foundation's Career Award. Professor Ramesh Kari co-founded the IEEE ACM Symposium on Nanoscale Architectures. In short, called as NanoArc, he served as program or general chair of conferences, including IEEE International Conference on Computer Design, IEEE Symposium on Hardware-Oriented Security and Trust, IEEE Symposium on Defect and Fault-Tolerant Nano-VLSI Systems, Nano RFID Security, WISEC, and he serves on several program committees like DAC, ICCAD, and many more conferences. He also serves as an associate editor of IEEE Transactions on Information Forensics and Security, IEEE Transactions on CAD, Journal of Emerging Computing Technologies, ACM Transactions on Design, Automation of Electronic Systems, IEEE Access, IEEE Transactions on Emerging Technologies in Computing, IEEE Design and Test, and IEEE Embedded Systems Letters. He served as an IEEE Computer Society distinguished visitor. He served as the on the executive committee of IEEE ACM Design Automation Conference, leading the security at DAC initiative. And he has given invited keynotes, talks, and tutorials on hardware security and trust. And there's a brief profile of his. And just imagine if the actual profile is read. I think we'll have to sit for a couple of hours here. So thank you so much, sir. You're here with us to share your experiences, give us a roadmap, a vision for achieving something good at a bigger scale and at a quality level in the department research activities, as well as we have also invited the circuit branches students, so they're also among us here. So thank you so much, sir, and thank you Rao Garu and Ravi Shankar Garu for really pushing up this and making this event happen here, and our colleague Madhav Babu Garu and all the other. Sorry, I'm not naming you, but all of you who are here, and we want many more events like this to happen. So I request Shashi Madam to give a small note, and then we'll progress this event.
Good afternoon, everybody. Today, we are having a great opportunity to listen from a very highly resourceful person, especially on a field which is current. That is, the topic is applications of generative AI in cybersecurity. Actually, the department is having a meaty project on cybersecurity and the related aspects like information security, education awareness. So this topic creates a lot of advancement in the students as well as research scholars who are aiming to look for the latest topics for their research and project implementations, etc., especially the final year students and others. So, with this brief, because of paucity of time, it is uh, my turn to uh, welcome our Ramesh sir to start his presentation. Thank you.
So, Dean Alumni Affairs would like to speak a few words because they are starting a mentor-mentee program. I would like to request ma'am to say a couple of words.
Respected Principal, AU Engineering College, Professor Seshi Madam, Professor Valli Madam, the head of the Department for Computer Science and Engineering, the rest of the faculty of the department, and Professor V.R. Rao Garu, the founder president of the Engineering College Alumni Association, Professor Ravi Shankar Garu, who is one of the 81, 85 most active batch of this engineering college. A very good afternoon to all of you. And most importantly, welcome you, sir, to this to Andhra University. It's a homecoming for you, and we are so happy that you have come all the way, taken your valuable time off, and addressing our students here. One of the vision of our Vice Chancellor, Honorable Vice Chancellor, is giving back to the university and how we get in touch with our alumni. That is our priority now. And he says giving back is not only in terms of finance and improving the infrastructure of the university, it is also giving back in the terms of expertise, like whatever you have learned and coming back and sharing it with us. Very soon this week, we are starting a mentor-mentee program where we have the mentors are the alumni of this university. And we hope you will register under the category and guide some of our students. It's a totally informal thing, sir. All you have to do is maybe they will give their choices depending on your interest and their interest. You can just get in touch with them, and definitely we can take our university the students, the quality of the students can be improved. Thank you once again and welcome you for this today's session.
So, with this, let us request Professor Rameshji to please go ahead with the talk. And later on, those who wish to interact with him, you're welcome.
Thank you.
Thank you, sir. Thank you.
So maybe we should start without the slides. I'll ask a few questions. How many of you are in the final year of your undergraduate degree, BTech, BS? How many of, oh, I see, six people. How many of you are in your third year? I see. How many of you are in the ECE department? How many of you are in the computer science department? Uh, data sciences? Do you have a program in data science? EE department, how many of you are in the EE? Is there anyone who is a master's, who is a master's student, MS student, or MTech here? So most of you are, oh, there's one, two, and then on the way at the back. How many PhDs are here? Oh, that's good. Did you find that over the last year or so, it's become easy to create papers? Papers better? How many of you think it's much easier to write papers. I think so. Yeah. I know, but so how many of you use AI for programming?
Assignments.
Yeah. How many of you? I think all of you should use it. Yeah. That's my. I think you should be using it. I use it extensively. Uh, yeah. But how do you know what the answers? How the answers are? How do you know they're correct or not? So we'll talk about those. Yeah. So they talk to each other, and hopefully they're all not. Email from PDF. Oh, email. How do I send an email? Wi-Fi password. Okay. Yeah. Mhm. Okay. Correct. Hmm? So, what languages do you program in? What programming languages do you use to do your projects, homework, lab? How many of you use C, Java? So how easy is it for, so what Gen AI models do you use? What version of cloud do you use? Do you have access to Fable? I Fable, right? Yeah. Uh, Grok? Anything else? DeepSeek. Haven't heard. So deep open source, yeah. Okay. How many about this side? How many of you use some of these? Any other models beyond these that you use? What's the part that you use here? Cloud? Cloud is quite good. So what's the problem with all of these models? What is the problem with these models? Even if it's DeepSeek, it's open, it's free, but some any problem with these models? Hmm? Hallucination. That's a even before you start using it. What's the problem with these tools? Hmm? Privacy. So privacy is a good problem. Is a good problem. Hallucinations are problems. What else? Context size. Context. What else? Yeah. Suppose you have a free. What's the encounter with the free model? Hosting requires a problem, right? So that's why having these large models, even if you have access to these models, you need a lot of money to host, even if it's a free model, right? Oh yeah. So now that so yeah, this is good. I should use both, or I should take just one. So anyway, thank you for the background. Uh, a big message, a key message is I don't want you to fall asleep at the keyboard, right? Uh, what you don't want to do is just arbitrarily accept any solutions that these tools give you, right? So you need to know if the answers are good or wrong or right, and so on and so forth. Early versions of the models used to give wrong answers even for simple math questions, but they have become quite good right now. For coding, it's still not as good. So the key message is don't fall asleep at the keyboard. Uh, do I? Yeah, next. Uh, so this is something we started at the very beginning before any of you had access to these Gen AI models. I think around 2021 or so, my postdoc Ben Hammond Pierce somehow got access to a beta version of GitHub Copilot. So that's when he said people were talking about even before this there was a GPT-2, which is even smaller version of it. So he asked this simple question: how good is the code that it generates? Right? One is, can it generate code? And all of us know that it can generate good code now. And at that point in time, it was generating reasonable code. So it's built on GitHub Copilot. I think this is part of Microsoft now. Nobody uses this as much. How many of you use GitHub Copilot? Oh, you do? Okay. How is it now? Fine. Okay. Uh, it's a powerful tool, generates code from comments. Did you try? So what language do you use the comments in? Sorry, I'll have a lot of interaction. So that's what I do. So what language do you use? No, for comments too, for prompting. How do you prompt? What language do you use for prompting? Why not Telugu? Right? I tried that too. It works, by the way. I tried Hindi. It works. Yeah. So you could use any language, but it's quite powerful. It's okay. Yeah, it's okay. Yeah, but I tried. So do you know why it's not okay when it's Telugu or whatever Hindi or something? So that's what it is. The training data that you have there, Stack Overflow, wherever it is, the comments are in English, the descriptions are in English, the textbooks are all written in English typically. So all of this data is what these models are trained on, right? So that's one problem. One is they're not good at generating good code yet. The second question that we were interested in is how secure is the code? How safe is the code that it automatically generates, right? So there are two questions. One is maybe it will say it is secure or it's not secure or it's some amount of security. The second question you may want to ask yourself is how secure is the code that experts write? Suppose there are experts who have had 20 years of experience. How secure is the code or how safe is the code that they write? So we did that study, but I won't talk about it. So what we noticed is if you have public code, everybody puts your code on GitHub repos and shares your repos. And this is what you use to get your internships and to get your jobs to prove that you have done something. And it's a good thing, by the way. When somebody sends me a GitHub repo, I do look at the GitHub repo and see what projects, how many stars, whatever it is, right? All of those things, people do look at it, and those are useful. So that's the data that the models use to train themselves on, and they do this repeatedly. The earlier versions were not as good. The more recent versions, like Claude, Fable, is really good. So they not only have good coding patterns, they have insecure coding patterns as well, right? So can we go to the next slide, please? So these are the questions that we asked at that point in time, circa 2021. During peak COVID, we had nothing to do. My postdoc was sitting in his apartment. I was sitting in my apartment, somebody else. So we were communicating and writing this paper remotely on Zoom. So now this is a general, are Copilot suggestions commonly insecure, right? How insecure are they? Is it very popular? That do you usually find all of these codes insecure? What percentage is insecure, and so on? The next question is, once you get an answer to this, the next question is you want to see what happened, right? If you say it's not insecure, why is it not insecure? And if say it's secure, why is it secure? Right? All of you type in questions. These are the prompts. So what kinds of prompts give you good code? What kinds of prompts give you bad code? Bad and good in terms of secure and insecure code. The third thing is, how does it perform in less common domains, like in Telugu, like in Naga, whatever is the language, and so on. So because there's not enough data for it to make reasonable guesses and reasonable inferences and reasonable next token determinations. So does its security perform change when generating code for languages that have less training data in public domain, right? Like hardware description languages. And that's where I bring in the hardware element of it. I do mostly chip design, so I have some interest in that. Thank you. So what we did is something very simple in retrospect, and you would have done this too if somebody asked you to do this, right? We designed a process to test the Copilot's code suggestions against. Is there a slide before this? Yeah, no, that's great. Yeah, you can go to the next slide. Yeah. So we wanted to do three things. We focused on the most vulnerable codes and buggy codes. These are called the MITRE rank bugs, right? If you just go to MITRE, it's an organization that compiles all code and sees which one is bad, and they rank them based on how many people report that as a bad code. We looked at the top 25, and we created different CWEs by asking different prompts, good prompts, bad prompts, and so on, to see what is a good prompt and what's a bad prompt. Uh, and then what? So now you are generating a lot of data. The process is very simple. Um, Perhaps these codes, you ask it to synthetically generate code, give a prompt, ask it to generate a program, and then you want to figure out if this particular program is secure or buggy or insecure. Uh, Imagine you have a scenario of 10,000 programs. Even if these are small snippets, you can't sit and verify the security of each of those, especially when there are 10 or 20 or 25 different bad ways of writing code, right? So you want it to, you'll have to be crazy to do that. So what you do is, once you create these programs, you want to have an automated pipeline where the tool automatically flags if there is a bad code or good code. For some bugs, there are these tools. For other bugs, there are not these tools. So what we did is we eliminated the bugs. We did not consider the bugs that could not be automatically checked, because otherwise it would take a long time. So we created this pipeline, generated the code, and ran it through this code QL is the code review tool, and use that pipeline to conduct our study. Let's go to the next slide, please. So we looked at 3 dimensions. So there are top 25. We said, let's look at top 10, whatever it is. That's the diversity of weakness, the range of weaknesses that these things generate. Diversity of prompts, good prompts, bad prompts, mediocre prompts, whatever they are, right? And the third is the diversity of domain that I talked about. Well-known languages, which is like Python, these models can write excellent Python programs. Even island programming, Python programming over the last 1 year using Gemini. And it tells you, if you have questions about the code, it explains what the code is, right? So, yeah. And then one of them is the hardware design language called Verilog. So we'll talk about that. Next slide. So that's the top line, bottom line, whatever you call it. We generated about 1,600 programs, 1,700 programs, and ran through this pipeline of automatically verifying how buggy or not buggy they are. And about 40% of these suggestions were vulnerable. And this is about 3 years ago. We haven't repeated that experiment. And for those of you who want to do a project for yourself, take the newer tools, run the same experiment. You can, along the same 3 dimensions, right? Take your favorite 3 languages, take your favorite 2 models and prompts, and just do the study, and you'll find something different and interesting as well, right? Yeah, next slide, please. So if you look at the deeper a little bit, Python is about 38%, or roughly 40%. C is 50%. How many of you even know C code? Right, some of you do. Yeah. Yeah. So these were some of the. So instead of all 25 CWEs, we only focused on the top 18 or so, because these could be automatically verified or checked and so on. Anything that stands out here for those of you who have used LLMs? What do you think the new numbers could be? So let's go back to the previous slide. Yeah, that's good. Thank you. So what's the message here for you? So you just can so you want to be careful when you generate the code, especially if it's production code that if you generate this code and deploy it in critical infrastructure and so on. slightly you introduce bugs that could be exploited by intentionally or otherwise by anybody that uses that. Huh? Yeah. Let's go to the next slide, please. Okay, sorry. Next slide, please. How many of you know, maybe should I go through this? This is too technical for those that are not interested. This is one particular prompt where you ask it to write print strings. Strings are whatever 47 characters long, and buffers are only 32 bytes long. So there is, when you ask it to write 47 bytes, it overwrites into the adjacent bytes, and there is some overflow, and that can create you some bugs. That's the high level buffer overflow attack. So things like that could easily be generated. Next slide, please. So this is the other thing, the power of context. If you have a lot of comments and good documentation, it usually does well. But in the early days, context size was a problem, right? Now you don't have a problem as much. At that point in time, there's a limited context size that you could use. And so you had to figure out what to put in, right? And the second thing is the way you name your variables. If you give them the right names, it could come up with the right things when you write programs. Coding style is also something that it has an impact that is impacting the outcomes. The other thing that makes a difference is the presence of other functions in the file. And the fourth thing is the if you refer to somebody's GitHub repo who has 5 stars, if you ask it to write according to a 5-star person's style, it usually does not introduce bugs. Unfortunately, as my postdoc pointed out in the paper, we are not expert programmers, so if we ask it to use our style, usually there's more bugs, right? Anyway, these are some of the, and we looked at 17 different variations of things like this, right? You could think of many more of those, many or different variations you can try. Some of them are still relevant, others are not relevant. Context size is no longer relevant. Yeah, next slide, please. So this is one example. When we added a good code, then the suggestions were all good. When we added a bad code as a prompt, about 17 out of the 18 suggestions had the bug. So context matters, right? The conclusion is presence of secure or insecure patterns in the existing code base, which is presented as the context or as the prompt to ask before you ask it to write similar code matters. Okay? Next slide, please. So that was the study that we did was on C and Python. But I have no interest in these 2 languages because that's not my research. So I asked my students to focus on, for this paper to go out, we had to do something in hardware. So I asked them to look into Verilog. Verilog is a hardware description language to describe hardware, and it's what's called a register transfer level language. But it's again, it looks like C, by the way. If anybody opens up a C Verilog code, it mostly looks like C code. Sometimes it does, so that's when there's some confusion. When it writes Verilog, it writes C code as well. And since this was such a less well-known language, and it is not as prevalent in the open GitHub repos, it wasn't good at generating good code, right? And there was no tooling to support this as well for automatic verification and validation and checking against bugs. There was no automatic checking tool. So this is where my PhD student, Balig, and a couple of others were acted as the manual verifiers. So the scenarios that we explored were not as many. Now there are many more that somebody could do. So the tooling at that point for verification and validation was less mature. So these were performed manually. And and most of the time the code that was generated failed because it was getting confused between C code and the Verilog, because Verilog code looks similar to C code. Yeah, let's go to the next slide, please. As I said, many suggestions had syntax errors. It was not even able to give some good code to compile and run and do simulations and so on. So, however, for the code that it did generate, it was surprisingly, counterintuitively much more secure because we focused on a small subset of hardware vulnerabilities and we evaluated manually. So, for whatever reason, you can't make too much out of this, but it was okay. Not, it was more secure or less insecure, as we call it. So that was the finding number 3. Let's go to the next one, please. So this is the bottom line, right? Because the code that these things are trained on typically have lots of buggy code, right? Most of you or most of us write code and put it on GitHub repos and so on. We don't write good comments. We don't use good styles for writing code and so on. So we have problems. So that's why you have lots of bugs. The commonly visible bugs in GitHub repos and so on also get into your code. So something else is what we noticed. Time is also a factor. What was good about 20 years ago is no longer good. For example, MD5 was a extremely good hashing function, a cryptographically strong hashing function. For those of you who have some interest in crypto, just take it there. It's a good security code. But in about 1999 or so, they showed that it's no longer good. But still, historic code uses MD5, so it's in the training data. So the code generated by models trained on these codes still use MD5 as a suggestion for hashing and so on. And there are lots of such nuances that you find when you carefully look at the data and analyze the data. Right? How am I doing on time? I can stop right here. I have 70 slides. Every time I go, I make 70 slides just to make sure that I don't run out of time. So let's go. So this is the bottom line, right? Don't accept every solution. You should be able to verify that the solution is indeed correct. So the bottom line for all of you is you need to know good Python. You should be able to write good Python. You should be able to write good C code. You should be able to verify that the code is good, whichever, so debugging and so on. You should build this intuition, and that comes with age, with experience, and so on. So as a first-year digital logic design student, or as a first-year programming language student, who, if you're writing Python and you just give it a prompt the night before your homework and say, give me a code for quicksort, right? That's the first question most of you have, right? Quicksort, recursive, iterative, and all of those things. Most of the time, maybe these days it's okay, but you don't learn anything, right? Once you know how a quicksort works based on doing it by hand, right? Take an example with about a heap of 20 different numbers and do quick sorting by hand. Then you can debug the code, right? Otherwise, you don't do well in your exam because usually the exams are a twist on the quick sort, right? And so that's the big message. That's one message for those of you who are beginning to use these Gen AI models. Don't do that. You won't learn much, and you'll fail more often than you will succeed, right? You can't just toss a coin and hope you'll succeed, right? So that's the big message, key message that I wanted to convey. In fact, I was teaching a class in digital logic design. I would teach on the board by using the regular K maps and so on and so forth. What book do you use for digital logic design? Morris Manor. Excellent. So it doesn't matter. So, right? And there's lots of examples and so on. So I forced my students to use Gen AI. I think whatever, each of them could use anything. And halfway through, they were so frustrated that they said, let's not use Gen AI because there are the twists that I would give are different than the twists in that these tools could do. But for those who are in your first year, second year, and third year, you should first know the language and only then use these as they call it co-pilots. Don't make them a pilots, don't make them autopilots, and don't fall asleep at the keyboard. Okay, thank you. Any questions? Oh, the other thing I typically do is share my phone number, right? I usually have it on my first slide or my email address, and you can call me, text me anytime, right? And I do this every time, but most people are afraid of calling anyone, right? So people are reasonable. So if you want, I can share my email. So now we don't even have whiteboards and blackboards. If we do, I can put my phone number somewhere. But yeah, like 917. You can share. Yeah, it's, you can put it up there. 917. This is a US number, but I'm on WhatsApp. 363 9703. Those are 917 363 9703. Just want to check that. Yeah, that's good. I didn't want to take up too much of your time. I think 4 o'clock was 3 to 4 was the timeline, right? As I said, I have 60 more slides. Okay, is it right? Yeah, that's plus. Yeah, that's my phone. You can text me on it, and I usually respond within about 15-20 minutes, unless of course I'm asleep. So if you send me, put your name and say you're from Andhra University, and I'll know who it is. Otherwise, I'll text back and say who are you, because there's lots of spam that goes on. So, any question about this topic? The other thing, maybe the other thing I can say is where I am from. So, you want to Google show the NYU website? Just say New York University. I'm from New York University. It's in New York City. It's in Brooklyn. So in case you're interested, someone was mentioning, talk about opportunities in jobs, programs, graduate programs, and so on. If you have questions about that, you can reach out to me. Yeah. It's not State University of New York. We are New York University. It's a private university in downtown. New York University is one of the largest universities. I think it has 65,000 students. Yeah. So yeah. So um, it's the School of Engineering has about 7,000 students. So, thank you. Yes, please go ahead. Talk is very nice. Very nice, sir. Because I am asking just general question, not related to your subject, because it is related to cyber security only. Nowadays, many things are happening. Accounts, no, even IG officers also they are facing problem. So, what is your idea about this? How to come out of this very important problem? Because most of the people are losing lot of money. So even people are asking when I landed in airport, he was asking me my details. He knows that I'm a professor of, I worked in BITS Pilani and all internationally. So he's asking many questions. Who are you? Why you are asking all these things? Then he ran away. Mhm. So I'm worried about this. So can you please tell me what research is going on this? Yeah. Because so many thieves are going on. See, this computer science is developing, but at the same time, these thieves are developing. Very fast. Yeah. So they also have graduate degrees in computer science, right? So, but that's one part of it. But cybersecurity is something has you cannot have a bug-free code, right? And even if a piece of code is bug-free and another piece of code is bug-free, when you combine them together, it's not there could be bugs. So what the plus point is that you'll have it as a cybersecurity expert, whatever that expertise means. You always will have a job because you cannot write nobody or there is no code that's bug-free or secure, perfectly secure. So that's the good news. And the good news for the attackers is every time you make something, they also can make something better in terms of buggy code. In fact, how many of you know ransomware? Right? Ransomware is an attack, and it required somebody with a PhD or even a master's or a hacker who knew exceedingly detailed uh, uh, information about the cyber physical system and so on to write as a ransomware. What we've shown is that using AI, the cost has gone down. You do not need to be an expert in to write a ransomware. All you have to say is write me a good ransomware, and they do excellent job. So just you have to be more worried. There's nothing you can do. So AI has gotten down the bar. So you do not even need to be an expert to write ransomwares and other attack code. That's the plus good news for the attackers. So yes, you should be worried.
So, sir has uh, an offer to us, and it's to attend his class uh, sometime between 7 and 8:30 in the evening,
Yeah. So
Indian time.
yeah. So what I do is every semester, uh, for about 14 weeks, I teach a class on Saturdays. Again, I don't have to do much, so I have no life. So I just show up on Saturday, sit in my office, and teach a class for a couple of hours on Zoom. It's not and with my postdocs and so on, we all come together, and it's it's about 11 a.m. New York time. So 11:30. We do it for 1.5 hours. If anyone is interested, let me know. I'll send the link to Rima, and she can share it with you, and you can do what if you don't like it, if you can't wake up, if you have a cricket match. I have seen all of these excuses. By the way, I teach this every semester. Sometimes you have a wedding, sometimes you have a party to go to, sometimes you have to watch an important cricket match. All of those are reasonable excuses because I don't do any of those things. Yeah, so
And one interesting part of that course is like it's advanced digital logic design. So chip related stuff.
so maybe you want to
And maybe mix it up with AI. But the most interesting part is the capstone project, which you can take up as your internship or project work. So if you're interested, I think we can structurize it somehow and okay, request him to take up.
So that's the, if you go to my GitHub repo, you will have about 20 different topics on this, and you can play with this. I don't pay for your tokens, right? So I don't give you, I don't put in my key there. So it will ask you to use your own key. You can use any tool. This is
So we'll work out on the keys, tokens, no problem.
yeah, but there are lots of free tools, so you don't have to use the latest. There's the tutorial and the slides. There's the, but it's mostly focused on digital logic design, testing, and verification, and so on.
So if you have any other questions, please come forward and you can interact with Rameshji.
Yeah, I don't eat people, so you can come talk to me. So, but if you don't want to talk in public, send me a text and I can respond to that as well. And I'm in New York, not in New York. I'm in Visakhapatnam for about today's 13th, 8 more days, 9 more days. 22nd, I go back to New York. So if you want to meet with me, I can also meet as well. Yes.
You said that you. Hello, hello.
Now, okay. Okay.
Yeah.
Put it close. Put it
The
close.
earlier you said that research is becoming easier with the help of AI, right?
Yes, go ahead. I'm listening.
So, what is your process of like verifying that the AI is doing actually correct work?
Excellent question. So, yeah, let me answer that question. For those who have expertise in a particular area, right, a mathematician who has proved theorems for their entire life, they know how to check an answer, right? They can verify the proofs that came out. These tools can generate proofs, but you cannot. You can ask it to prove the twin point conjecture, whatever it is, or some other stuff. But I don't have the expertise to verify the proofs of some of these things. So you need to have your. It's becoming easier for those that have a core expertise, and then you can do ask work with this as a co-pilot to do more research and of course verify the results. So you should be able to still verify the results. That's where it becomes easy. So as an undergraduate, again, my statements were it's becoming easier, but it's also harder because you have that attraction in front of you to get to chat GPT, not thinking I do the same. I'm at a stage where I don't care, but you're at a stage where you should care, where you shouldn't use chat GPT or Cloud as your first instinct. That shouldn't be your right. So you got to try it out. So for all of us, the alumni, the 81, 85, we did, each of us did about 1,000 integrations within a week, right? Wow, right? Right, Babu? Right, right? We used to do a lot of integrations as homework. 1 week, we used to get 1,000 integrals that we had to do. I don't remember many of them now. Differentiation, various things. So you need that mental exercise. And Monica Vachagam Pillai. Exactly, Pillai. Yeah, exactly. Books, and we used to do so. Now we have an instinct of checking the answers. So we know what the answer should be. So you need to build that instinct, and that takes about 5, 10 years, right? Of course, you should still use the tools, but don't rely entirely on them. Yes. Anybody else? Questions? So for those who are doing a PhD, does anybody use AI?
Yeah, all of them.
Yeah. Yeah.
Maybe for the problem statement as well, they ask ChatGPT which statement to take.
Yeah. So I have a different thing. So again, I've been thinking about this for some time. So what I want when I wrote my PhD, I don't have a GitHub repo for my PhD thesis because this is a long time ago. So now I'm saying, can AI recreate my thesis? That's my question, right? My research question is, can AI recreate and reproduce and write the C code that was used then? I don't have it because we never used open repos and so on. Or Babu's PhD thesis, he's a PhD from IIT Kharagpur. Whoever, can you recreate those PhD theses? Right? That's an interesting question as a research question. So,
I would request all the 81, 85 batch of alumni to please come over onto the dais. We'll have a group photo. All the teachers, please come. Sir, Lindred. So let us all put our hands together for 8185 batch for making this happen. And we look forward for that lecture which sir is talking about. So we'll work out on maybe we can attach it as a MOOC instead of some other external MOOC. We'll see how to figure it out. But yeah, that AI and chip design really matters in the future. So I think we have to have a look at that. So a small announcement. Tomorrow we have the BTH Sweden University, uh, administration and teachers coming in over. One of them is an expert in AI. So we have requested for a talk again from that professor. Okay, I think I have shared you. Uh, if not, you can just have a look at it again. Okay, please attend it. It is in the civil engineering seminar hall. Okay, that is the next one. And day after, on the 15th, we have a professor from IIT Bhubaneswar coming in. He's again a very good researcher in AI and an expert. So he'll be addressing us. Okay, that will be again. I'll share the venue and all. Right. So with this, thank you all. We'll meet again tomorrow.